Alright, I hope this video helps you do your Half-Life stuff today. So, Half-Life's pretty easy. It can get a little bit complicated. Most of the ones that are complicated I made optional on that form, but if you have time to do it in what would be a normal class period time, then please do it. That's good for you. So it's just after a half-life amount of time, like for radium-226, after 1600 years, if you start with 100 atoms, after 1600 years you'll have 50 atoms. And the other 50 will have decayed into something that's not radium-226, because it's radioactive and it means it's unstable. And it gives off all sorts of dangerous stuff that we'll learn more about later on its way to decaying into something that's not radium-226. So I'll make a little chart here. So at 0 years, let's see, if we start with 8,000 atoms. So at 0 years, we have 8,000 atoms. After 1600 years, one half-life, then we'd have 4,000 atoms. So it cuts in half each half-life. And so after 1600 more years, that's 3,200 years, like this question's asking. I guess, say years. Okay. 4,000 goes into 2,000. So there you go. 2,000 is the answer. Now, some of these questions might ask, so if you started with 8,000 atoms, how much would have been there 1,600 years ago? So then you'd have to go backwards. It's like, okay, I know every 1,600 years they cut in half, but 1,600 years ago, so it would have cut in half from that. So that would mean that if there's 8,000 now, there would be 1,600 years ago. That's not what this question's asking, so I'm not writing it down, but the rest of those questions are kind of the same. So these are kind of the more complicated ones, and these are the optional ones, but I want you to know how to do it. So the half-life of this isotope, iodine-125, by the way, when it says iodine-125, that it's different from regular iodine because it has more or less neutrons, usually more, and 125 is its atomic mass, and that's how they identify it. But it's those extra neutrons that make it unstable. So this is asking what fraction will remain. And it's kind of easier because you don't have to start with a number of grams and cut that number in half and do math, because you know after one half-life there will be half of it left. So after 360 days, let's see, if the half-life is 60 days, then 360 days is 6 half-lives, right? 3 to 60 divided by 60 makes 6. So I'm going to number out to 6 here. So after one half-life, there'd be one half of it left. It's asking what fraction will remain. So we're just going to have to keep going here. So half of a half is a fourth. Half of a fourth is an eighth. Half of an eighth is a 16th. Half of a 16th is a 32th. 32th, is that a word? Half of a 32th. Half of a 32th is a 64th. So that's the fraction that would remain. So there's a question that asks like that, and you have to go super far. I think the answer is 4096, but we'll see about that. What the other one was doing? This one I'm going to have to do math. So, we got radium-226 again. Apparently it's 1602, not 1600. But the other one must have been rounding. It's fine. So 9612, huh? I don't know how many half-lives that is. I'm going to need my calculator. Where'd you go? Calculator. Hello? Oh, find it. What we got? 9612 divided by 1602. 6. That's 6 again. So we already know we could just multiply it by a 64th if we want. Or we could divide it by 2 a bunch of times. So either you can put in your calculator Because we know what fraction of it will remain after 6 half-lives. It's a 64th. So you could say 500 times 1/64th. How do you write numbers? Okay. Or you could say 500 divided by 2, divided by 2, divided by 2, divided by 2. And count to 6. So 1, 2, 3, 4, 5, 6. You could do, because you cut it, all you need to do is cut it in half 6 times. That's 6 half-lives. But I'm doing it backwards, aren't I? Dang. So this doesn't actually apply. Okay, so what we need to do, it says how many would have been present 9612 years ago. So this is how to do it if you were saying, okay, how many would be left? And you could do that, but that's not the deal. So instead of dividing, because 1 half-life ago there were 1,000 grams, so we multiply by 2. So we can just change all of these lines into times signs. And this is the way I recommend you do it. If you don't do it this way, if you try to make it into a formula like that, you're messing with powers, and I don't want to do that. That makes it complicated and you're more likely to make a mistake. So I'll go ahead and do it, I guess. 500 times 2 is 1,000. Times 2 again. Let's see. I'm going to say that's 1,000 times 2 again is 2,000 times 2 again is 4,000. Oh, I just did 500 times 2 on a calculator while I'm on video. Sad. We can do this though without a calculator. 500 times 2 is 1,000. That times 2 is 2,000. 4,000. 8,000. What do you got? 16,000. And 30. Wait. Okay. 32,000. So there you go. 32,000 grams. That's a lot. And that's how you do some of the non-required ones and the required ones. I hope that helps with your half-life of practice. I'm gonna have to wait to post this video maybe during lunch.